In this lesson, we will learn to use the properties of determinants to simplify the expansion of determinants by minors. Property number 1 says if each element in any row or column is 0, then the determinant is equal to 0. So for example, here we see this entire first row is all zeros. So if I find the determinant of this, we'll find that the determinant is equal to 0. And we'll prove that. So if we were to find the determinant of this matrix, we can expand by any row or column. So we can expand about the first row. And when you do that, you want to expand or find the minor of each of the elements in that row. So here we find the minor of the 0, this first element. So we eliminate the row and the column. We're left with 3, -1, 2, -2. And then we look at the second element, so the second 0 in the row, and we can find the minor of that 0. And so now we have 2, -4, -1, -2, and you multiply by that element, the 0. Same thing for the third element. We can find the minor of the third 0 by eliminating the row and the column. We're left with 2, 3, -4, and 2. Then you multiply by that third element. So notice for each of these we have 0 times this determinant minus 0 times this determinant plus 0 times the third determinant. Well, you don't even really need to find the determinants of those matrices, but if you did, you'd find that they were -4, -8, and 16. But from here we multiply by 0, so all we have is 0 minus 0 plus 0, which would just be 0. So once again, if any row or column are all zeros, then the determinant would equal 0. Property 2 says if two rows or columns of a determinant have corresponding elements that are equal, then the determinant is equal to 0. So for example, we see here we have the second and third row are identical. So that means that the determinant will equal 0. Now to show that to be the case, we can expand this by minors using the first row. And so using the first row, we would find the minor of the 4. And so we eliminate the row and the column. We're left with 3, -1, 3, -1. We can find the minor of the 1. We have the matrix 2, -1, 2, -1 left over, multiplied by the element 1 that we are finding the minor of. And then do the 2 as well, the third element. We find the minor of 2 by eliminating that row and column. We're left with 2, 3, 2, and 3. Then you multiply by the element 2. So when you solve this, the determinant of the first matrix, you'd have -3 minus a -3, which becomes a 0. The second matrix, you have -2 minus -2, which is 0. Third matrix, 6 minus 6, which would also be 0. So what we have is 0 minus 0 plus 0, resulting in the determinant equaling 0. So once again, if you have two rows or two columns that are identical, then the determinant would equal 0. The third property says if two rows or two columns of a determinant are interchanged, then the resulting determinant is the opposite of the original determinant. So for example, here we have this matrix, and if you were to find the determinant of this matrix using the first row, we can eliminate that row in the column containing the 4. We're left with 3, -1, -2, 1, multiply by the element 4. And then find the minor of the second element of the 1. So we're left with 2, -1, 2, 1, multiplied by the element 1. And then the third element, the 2, we can find the minor of the 2. We're left with the matrix 2, 3, 2, -2, then multiply that determinant by the element 2. So when you solve this, the first matrix, you have 3 minus a +2, which gives me a 1. Second matrix, you have 2 minus a -2, which gives me a +4. Third matrix, we have -4 minus 6, which gives me a -10. So we solve this, we have 4 minus 4 minus 20, which gives me a -20. So now if you were to interchange the first and second column, so looking here at this column and this column, if you were to change them, so now we have 1, 3, -2 in the first column, and then 4, 2, 2 in the second column. So as we see over here, we interchange those two columns and then find the determinant of this new matrix. So doing the same thing, and we eliminate the 1, we find the minor of the 1. So we have the matrix 2, negative 1, 2, 1, and then multiply by that element 1. And then find the minor of 4. We're left with 3, negative 1, negative 2, 1. And you multiply by the element 4. Same thing with the third element. You find the minor of the 2. So you have 3, 2, negative 2, 2. Multiply by the element 2. So here we have 2 times negative 2, which gives me a 2 minus negative 2 gives me a positive 4. 3 times 1 is 3, minus 2 gives me a 1. So we multiply by 1. Here we have 6, and then minus a negative 4 gives me a positive 10. So now we have 4 minus 4 plus 20, which would give me a positive 20. So notice we started with the determinant equaling negative 20, and then when you switch those two columns, we have the determinant equaling positive 20. So if we exchange two columns or two rows, the determinant will be the opposite of the original determinant. Property 4 says if each element in one row or column of a determinant is multiplied by a real number, then the determinant is also multiplied by that real number. So for example, using the same matrix that we just solved, you find the determinant, and we've already done this. Your solution would be negative 20. But now if we were to multiply that first row by a 3, so take 3 times the 4, 3 times the 1, and 3 times the 2, and you were to find the determinant of this resulting matrix. So when we do that, everything stays the same except for the number in the front is going to be different. It's going to be 3 times that number. Right over here was a 4, now it's a 3 times 4 for that first element. Here was a negative 1, now it's a negative 3 times 1 over here. And then over here was a 2, now it's going to be 3 times 2 for that third element. So the only thing that's changing is the number that we have in the first row. We multiplied everything by 3. So we already found the determinant of each of these three matrices, where the first matrix, the determinant is 1, second matrix, the determinant is 4, and the third matrix, your determinant is negative 10. So when you solve this, you're going to get 12 minus 3 times 4, which is 12, then plus 3 times 2 times negative 10, which gives you negative 60. Notice you're going to get negative 60 as your determinant. Well, if you look at the original determinant of negative 20 and the new determinant of negative 60, notice that we had to multiply by 3 to get to this new determinant. And that is because in this first row up here, we multiplied every element by a 3. So therefore, my determinant would also be multiplied by 3. Property 5 says if each element of one row or column is multiplied by a real number k, and if the resulting products are then added to the corresponding elements of another row or column, then the resulting determinant equals the original one. Now that is a lot of words and it's kind of difficult to understand. So let me walk you through with an example of how this fifth property works. So what we do is we take a row or a column, and in this case we'll take this second row. So take the second row and multiply it by some number. So we'll multiply it by the number 2. It can be any number. Let's multiply it by 2. So we multiply every element in this column by 2, and then whatever that is equal to, we can add it to another row or column. So we take the 1 times 2, the 3 times 2, and negative 2 times 2. We're going to add it to this first column. So now we have 4 plus that 1 times 2, and then 2 plus that 2 times 3, and then here we have the 2 plus that 2 times negative 2. So when you do that, we have 4 plus 2 equals 6, 2 plus 6 gives me the 8, and then 2 plus negative 2, 2 plus 2 times negative 2 would give you a negative 2 right there. So this first column is being replaced with 6, 8, and negative 2. Now if you were to find the determinant of this new matrix, the fifth property says the resulting determinant equals the original one. So let's find the determinant of this new matrix. So if you were to expand using this first row, so we are going to find the minor of 6, 1, and 2. So we eliminate this row and column. We're left with 3, -1, -2, and 1. Then you multiply by that element 6. And then we're going to do the same thing for the second element. So find the minor of the 1. We have 8, -1, -2, and +1 for the matrix, and you multiply by the element 1. And by the way, this is going to be subtraction. So we subtract this one, and the third one we're going to add, and you find the minor of the 2. So we're left with a determinant of 8, 3, -2, -2. Multiply that by the element 2. So from here, we can find the determinant of each of these three matrices. 3 times 1, we have 3. -2 times -1 is +2. So we have 3 minus 2 equals 1. Next matrix, same thing. 8 times 1 gives me 8. -2 times -1 gives me a +2. So we have 8 minus that +2 equals 6. In the third matrix, you have 8 times -2, so we have -16. Minus -2 times 3 gives you a -6. So -16 minus a -6 would give me a -10. So now we have 6 times 1 minus 1 times 6 plus 2 times -10. And that's going to give me 6 minus 6 plus or minus 20, which will be -20. So all that to point out the fact that the original determinant was -20, and then when I multiply the second column by a number, we picked the number 2, and added it to any of the other columns, then the resulting determinant would also be the same. And that is your fifth property. And that concludes our lesson for today. We will see you next time.